We are going to do a video on advanced analysis parts and models. In the lab 1 we are going to do placing and editing the advanced analysis parts. Open the capture and select the file and a new project. Name the project as my cascode and set the location and browse it where we have to put the file and select OK. In the create PSpice project, make sure that it should be the location where we have to save the project and click OK. Then the required OPJ file gets open. Now make sure that we have to delete the D1, Q1 and Q2 transistors. Go to the place and select the path, and in the path dialog box click add library and look into the libraries, and with the control key select the bjn.olb and dizolb and select OK. In the path field select 1N755 and click OK and place it in the required location. Similarly, select the place and the path as 2N3724. Click OK and place in the required position. Similarly, do for the 2N5179 transistor.
2N5179.
Once it's done, save the project. Make sure everything is placed properly, and now we are going to do the editing advanced analysis models. Select the D1 diode and edit the properties. Change the model name to AWB MY1N755 and enter. Go to file and save the library. Similarly, do the editing for the 2N3724 model. Select Q1 transistor. Do the same procedure which I have done for the diode D1 and replace the model name as required and go to the file and save. In the simulation parameters, make sure the values are set to the required. Set the BF postal and negatol to 40%. Similarly, CJE to 20% and CJC to 20%. And save the file. Now similarly do the editing model for the 2N5179 by selecting the transistor, right click and edit the PSpice model and change the model name to AWB MY 2N5179 and set the values to the required as CJE to 20% and CJC to 20%. And go to the file and save the library. Now we are going to do the summary and cleaning up. In the capture, double click the Q1 transistor and make the changes required in the display properties. Make sure that the display property is set to do not display and click OK. Then select the Q1 transistor in the capture and select the implementation from the list and make sure that it is set if you require the name and value and click OK as shown in the figure, and similarly repeat the steps for D1 and Q2. And for Q2 transistor, implementation, select the display property and name and value and click OK. If required, we can verify the files in which the desired location the piece files are there if required, or go to the file and save the project. And we are going to do the now in the second lab as sensitivity analysis. Go to the file and create the new project name as Sense Cascode and make sure the file is saved in a certain location and browse it where you want to save the file and click OK. Make sure the create based upon a existing project is marked and make sure that my cascode.opj file is shown and click OK. Now we are going to do the component tolerances and defining the global tolerances. Click on the variables if the copy of sense cascode variable symbols are present, just select them, click on the variables and double click the CTOL property and set the value for 10. Similarly for RTOL to 10 and LTOL to 10, and make sure the global parameters like VTOL and ITOL are defined to 0. In the capture, zoom in into the capacitor C2 . Make sure double click the capacitor C2 and set the value of postal property to 20% and negatol to 20%. You may set the display properties to be visible or not to be visible, it's the choice. Then in the capture, similarly make sure do the same procedure for the R4. Set the value of postal and negatol to 20%, not 20%, make sure that it is set to the 0. And return to the capture. And now we are going to define the simulation profiles. We are going to define first the DC simulation profile. Go to PSpice and select the new simulation profile and name the simulation profile as DC and click create. In the analysis type, set it to the DC sweep, and the sweep variables, name the variable as V3. In the options, make sure it should be primary sweep and select the value list and set to 0 and click OK. Similarly, set the AC simulation profile, create the simulation as AC and click create. Go to the analysis type and make sure it is AC sweep, and the options as general settings, and make sure that AC sweep type start frequency is 1 MHz to 600 MHz and the points of decay to 100. Click OK. In order to assigning the tolerances to the semiconductor devices, we can either run the DC or AC profile. We are going to do the AC profile. Just click on the configuration files tab. Just we are going to trace the as VDB of out. This is the graph. Now we are going to evaluate the cutoff frequency, which is evaluate the measurements as cutoff of low pass of 3 dB and trace it as V out. Search the required V out and select the V out and click OK. Then the measurement value is displayed as shown. Similarly, evaluate for the maximum of VDB out. And click OK. We are going to see the value. We got the 14 point some change. Then we can do the similarly, run the AC profile, simulation profile. Go to the simulation and open the AC simulation, or we have seen the AC. Now we are going to do the DC simulation profile. Make sure that its measurement analysis is on and evaluate the power and the current dissipation of the transistor Q2. Now we are going to add the measurement for the current, collector current of Q2 transistor, and similarly we are going to add a measurement for the power dissipation of Q2 transistor. Q2 and click OK. Now we are going to see the running sensitivity analysis. Go to the capture window and select the PSpice. In PSpice, select the advanced analysis, select sensitivity. The advanced sensitivity analysis window appears. Click on the Click here to import the measurement created within PSpice, and holding the shift key, select the required values and click OK. We are going to see these are the measurements which we have selected, and in order to run this, we have to go to run and run sensitivity. We are able to see the analysis. Once the analysis is complete, you can see the different sensitivity curves for the low pass of cutoff frequency with the maximum dB. We can observe the different parameters and the maximum and the minimum value and absolute sensitivity of the measurements. Now we are going to see the 100%, that is the maximum for the cutoff low pass measurement. Similarly, we can see the other measurements by selecting the required. This is the power of the transistor, bar graphs with the different parameters. If you want to print the screen, you can print. If you want to view the log file, go to view and log file and sensitivity. This is the sensitivity log file. Just close the sensitivity log file. If required, save the project and close the window.